So hello everyone, my name is Bal Krishna and today we're going to look into my C project written in C++ language and uh, basically its name is Connect 4 and it is a game that we'll discuss about before going into the code part. So first of all, let's start. This is the project title, the Connect 4, and this is my name is Bal Krishna and the enrollment number here. So many of you might not know what is Connect 4, so I'll briefly describe what is Connect 4. You must have known the tic-tac-toe game, right? It is a 3x3 grid in which you have to connect your three of your symbols. Your symbol could be like the cross or the circle. So basically you have to connect three of your symbols consecutively, either horizontally, vertically, or any of the diagonally, right? So basically you have to connect three consecutive of your three symbols, right? So the Connect 4 can be thought of as an extension of to that the tic-tac-toe. In this you have to connect 4 instead of that in 3 in tic-tac-toe, but there are some two major differences. The first of all, the first difference is in this game there is a term called gravity, right? You must be familiar with what is gravity. So basically you can only choose the column. In tic-tac-toe, remember, you can precisely choose which row and which column you want to put your symbol in, but in this game, as you can see, both the boys playing this game, suppose he chooses this column, so it will fall into the lowest available column, that is this one in this example. So, and that it will be placed there. He can't choose that I want to choose this row and let's say this column and I want to place it here. No, you can't place it here. You can only choose the column and it will fall into the lowest available row available in that column, right? I think it's now it's pretty obvious that how would you do that. So basically you just have to play, you just have to use strategy in this, and so that you could just consecutively make your symbols 4 consecutive, either horizontally, vertically, or any of the diagonally to win the game. So that's how you'd win the game. I'd also give the definition of the bookish definition of Connect 4. Connect 4 is basically a 2-player abstract strategy game played on a vertical grid. The objective is to be the first player to form a continuous line of your color token, right? Basically if he's playing with the red token, so he have to connect the 4 consecutive red tokens either horizontally, vertically, or diagonally, and players take turns dripping one token to any column, and you have to be basically the first player to connect 4 of your tokens, right? So with now I hope you have understood what is Connect 4. So first of all, what we have seen here, that we have used colored tokens here, right? The word color token was used, but if you have noticed, C++ is very text based and very monochrome type of environment. You don't see too much colors in the terminal of the C++. So how would you achieve the color part? So that's the challenge. Basically the challenge is the C++ console is a simple text based environment that appears very monochrome by default. How would we use colored characters in the terminal so that it could be visually appealing for the players and for the audience, right? So how would we do that? How would we use the colored characters in our C++ project? So the solution for this is ANSI escape codes. What are ANSI escape code? Basically these are special commands that tells the terminal that wait, now what I'm going to give you the text, write these texts in not the white and the usual white and black color, but try to write it into a specific color and specific style that I will be providing, right? I hope that you'd have understood, because obviously I have not explained it elaborately. I'll explain it later in the next slide. First of all, I'll give you the brief intro. How it works: instead of being printed, these code instruct the terminal. These codes basically instruct the terminal that now switch to the red text. Now the next text should be in the red color, right? As you can see here, my symbol cross is in red color. So how did I achieve that? I told the terminal or the compiler before using this that, oh, hey, now the symbol I'll be providing, put that in the red color, and similarly with this blue box and the yellow circle. How did we do that? Let's look into that. Basically the use of ANSI escape codes. Basically this symbol, I'll explain one of these and you'll get to understand how others work as well from this example only. So first of all, I'd also describe these conditions. So basically include iostream. What is include? Hashtag include is basically when you include a library, a predefined set of codes that you help you to make your codes easier, right? That you don't have to do all the work from yourself. There are some pre-described codes, you could use them, and then you can start from that, and you don't have to start from very scratch for the compiler. Like you don't have to start from like 0 1 or that's why compilers are made, and that's why these are some libraries that, for example, this include iostream library used for you to give the function of getting the input, basically cin, and giving out the output on the terminal, basically cout. So basically iostream gives you the freedom or gives you the power to unleash these two type of functions, the cin and the cout, right? What is include vector? Vector is basically a type of array. We'll understand what is array in the later part of the video, and basically vector is just like that, we'll understand it later. String is basically a kind of like text or a paragraph, something like that, in a text of or a paragraph, right? It is something like that. If let's say it is like written as hello world, so basically hello world, double quotation here, double quotation here, so that becomes a string, right? So string is basically just like a paragraph. In English, just like you write the alphabets or the letters as that correspond to the chars in C++. In English, you write alphabets or letters that corresponding to chars in C++. And when you write like whole number of words or like one word or a paragraph, all that correspond to string in C++, right? Using namespace standard, basically that defines that when we are using the cout, that the compiler may not know what is cout and what is cin. So basically we are using the standard terms in the compiler. So basically when you are using cout, the compiler should understand that we are using it to giving output on the terminal, and it is not some random cout that are made by ourselves. So this is the purpose of using the namespace standard. Basically when we're using some standard terms, the compiler should know that, right? Now we are defining this, the use of ANSI escape codes. So basically when we define constant are basically, we don't want these to change anywhere. Why? Because see, this is a global variable, we are defining it before the int main function. So these, and not in any type of sub function, we are defining it in a global scope variable, right? So basically when we do that, that means that it can be accessed in the whole part of the code, anywhere in the code, and that can basically lead to a problem. What's the problem? The problem could be that it can be changed anywhere in the code, in any sub function, in any function, because since it is a global variable, it could be a risk of that it can be changed anywhere in the code. So that's why we define constant here, so that it does not get changed anywhere in the code, right? So constant string red, constant string yellow, constant string blue, constant string reset, and these are all constant. What does this red, yellow, blue reset means? See, the first of all, there is a backslash here. The backslash here defines that this is not a simple text, this is something else. This is not just a normal string that you want, this is something else that we'll understand later, right? This 033 is basically an octahedral form. It is written in octahedral, just like you know the binary form. It is you can get the binary number into the decimal number. You can also get the octahedral form into the decimal system. How could you do that? Just multiply this into this with the 8 raised to power 0, this into 8 raised to power 1, so you'd get that. So basically it is 3 plus 3 into 8, that is 27, and 27 in the ASCII code correspond to the escape characters, right? So basically this means that this is a type of terminal. It tells this terminal, it gives a signal to the terminal that the following, the something that is going to be there after this one, it is a special command, right? So that's how compiler knows that now there is a command coming instead of just text, right? This the left column or the left bracket, this is the control sequence introducer. Basically as its name suggests, introducer. So basically it introduces the command sequence. So basically it lays the beginning of this special command here, right? Now coming to the 131, so basically these are the codes for the specific function. This means the bright or bold type of text. Basically this is the type of style of the text, and separated by the semicolon. This 31 means the color of the text. So basically 31 stands for the red color. So basically when you write this and we define red as this, so now when I see out red and then see out some text, then it will be displayed in the red character, and this 31 means the red. So if you want to describe the same bright or yellow, bright or bold type of text but in yellow color, so we would keep everything same and just change it for 33 that correspond to yellow, and 34 to that corresponded to blue, right? But again when we use this, then that all the text after this would be appear in this red color. So we want that to be changed, and that we want that to be come to the default part as a normal C++ compiler. Then we use that reset, and reset is this code is for the normal, the C++, the white color basically. This is used for the white color. Now we are defining constant int r and c. Basically r means here row, number of rows in the box of the Connect 4 game, and the c describe the number of columns, and the constant char empty. Basically I'll describe it in the later part of the code. Basically when we have the code, we are just starting the game, we'll put all the characters as dot first, and that would describe that these are empty, and p1, the player 1 has a characteristic symbol of cross, and player 2 has its characteristic symbol of 0 or O, and this is a 2D array of b. Basically it is a 2D array that in which every data type is char type, and it is name is b, and it has r number of rows. Remember, now whenever I'm using the capital R and the capital C, this refers to these global variables because it can be accessed everywhere, and that refers to these rows and these columns. So basically we are creating a 2D array of 6 rows and 7 columns. That's name is b, and all the data type in it are char type, right? So that's how I describe. And also the m here in this line, this is the final character that specifies the command. The m character is called select graphic rendition, which set the display and attribute. Basically it just display the code you've used here, 1 and 31. It just helps to compiler to basically use that 1 for bright and bold, and 31 for these red, and similarly for 33 for yellow, and so on. So now coming to the sub functions part, we have understand how we are using the colored character that we were discussing here. Now we are going to learn about some basic of the sub functions. What are sub function and what are the kind of sub function that we're using, because our function is using 5 or I'd say 6 sub functions in our code. So that's kind of too much subfunction. So I'll first define what is subfunction. What is subfunction? Subfunction is a named block of reusable code that performs a specific task. This is a kind of bookish definition. What does it mean? Suppose you have 10 numbers, 1 2 3 4 5 6 7 8 9 10, right? These are not number, I'm just saying there are 10 numbers, right, divided into pair of 2. So basically you have 5 pairs of number, and there's n for every number, and there's r for in each pair. You have given a integer n and given an integer r, and you have to find NCR for all these 5 pairs. I'm just taking a small example of 5 here. It can be even magnified to 500 or something. I'm just taking example of 5 pairs. So what are we imagine we have to do NCR for calculating the NCR for these 5 pairs. Now I don't want to write the code of factorial always again and again for like n factorial for each number, for r factorial for each number, n minus r factorial, because you know the formula of NCR is n factorial by n minus r factorial r factorial. So I don't want to calculate these for all the pairs every single time. So I'm defining a function that does that task always for me. Basically think of as when we write in mathematics, we write 5 into 4 into 3 into 2 into 1 as 5 factorial, right? So it when we if I was, it would have been defined just to minimize that text. When there were many instances where there was a particular kind of thing was appearing. Let's say it is n into n minus 1 into n minus 2 and so on till the multiplication till 1. So everyone would have thought as, okay, let's define it as n factorial. We don't want to write this much amount of every time, right? This much information every time. So that's why the function of factorial would have come, right? So similarly in C++, we don't want to write the similar type of code every single time again and again and again and again. So we just define it as a factorial. So basically it is the we have named the subfunction factorial, and it is this int here refers to the return type of this subfunctions. Factorial is the name of the subfunction. This here is the return type of the subfunction, and this is here is the input type of subfunction. As I gave the example of factorial, let's say I have given a I have to calculate the 5 factorial. So when we calculate 5 factorial, 5 is here, right? Factorial is here and equals to 120, right? So 5 is taken as input, factorial is some processing, and 120 is the output, right? So 5 is an input, factorial does some processing, and 120 is the output. Here again similarly 5 is the input, 5 is an integer, this is the processing, and you can understand it is very easy for loop, and you're multiplying the you're initializing the fact as 1 and you're multiplying all the natural numbers till n to this. So basically that that returns the answer of factorial. So basically this is the return type and this is the answer. So this is very similar to how you define them in mathematics, right? And similarly when you define NCR, you take inputs as integer n and integer r, and you do the operations of factorial n by factorial r into factorial of n minus r, right? Obviously there are edge cases. If r is greater than n, that will obviously mean that there is no choice or zero ways. So basically that means that we can now calculate the subfunction of any n r inputs easily by just writing this line. Now we can use just one line for all the, like if there are 500 pairs, we just write one line for each of the pair. Now we don't have to write this much amount of information for each pair. That would be very hectic, right? Also there are some kind of rules that we are going to use. First of all, the NCR, notice how we are using another subfunction in the NCR subfunction. We are allowed to do that obviously because we are using it, but notice one thing, this factorial the compiler of C++ do the processing line by line. So when the compiler comes to this subfunction and he notices that there is a factorial term here, it should know that there was earlier a kind of factorial defined before this line, right? So you have to define this factorial before using it here, right? And similarly when you're using NCR subfunction in the main subfunction, in the main function, you should have defined it earlier before the main function, right? So basically just like I said, the main function, think of it as a manager, and the manager's job is to delegate tasks to specialist workers, and here all the subfunctions are specialized in their works. Just imagine you want to study physics, right? So you'd obviously study physics from a professor who has done further studies in physics. So this is basically he's specialized in physics, so you want to study physics from it, right? It is very similar to that. You want to do some specific function, you call a specific specialist subfunction for that, right? I think I've explained subfunction quite deeply. Now let's move to the what are the subfunctions that are present in our code. So basically there are 6 of subfunctions, and notice there are 3 of some bool type, 2 of int type, and 1 is void type. I'll explain what is this. And also you would have noticed that there are some brackets in which there is nothing written, and there are some bracket in which there is something written. What are these? I'll explain it, right? So first of all, talking about the bool part, as I've said, the data type written here before the name of the subfunction, it is basically the return type of the subfunction. So basically the boolean type means, boolean is basically true or false. Basically this subfunction will return either true or false, either yes or no, either 1 or 0, kind of similar type of analogy. So basically this will return true or false, right? Integer will return obviously some kind of integer, and if there is no kind of returning, if there is a subfunction which does not return anything but do some work, like it print something, like just the name suggests print board. So let's say it print the board, but it does not return anything. It does not return true or false. It does not return integer as 5 or 6, nothing. It does not return anything, just print the board. So in these type of cases, we put the data type as void because it is not returning anything. And for the input parts, there are some of the sub function which have to take the inputs to so as to process something, like the example of 5 factorial, in which you have to take the 5 as input, then you can calculate the factorial of it. But there are some sub functions which does not require the input, any kind of input, and we'll explain it. Just like the printing board, it just print the current condition of the board, it does not take any input. We'll explain this course later in the function. And notice how I have defined all these sub functions before the integer main function, and I'll explain, or I'll elaborate its function after the main function, so as it does not become messy. Like let's say a coder wants to study your code, and he'll see all the sub function defined too much before the main function. It would be very hectic for him to scroll through and always understanding what is happening. So basically he will what you should do is you should just write and define all the sub function, and you can define its processing after the main function. Okay, so here are some things that I've written. Basically it is related to our sub function. We'll discuss it later, so let's skip that. What is an array? Why I'm defining array? Because when we are printing the board, it is a 2D array. Basically it is a kind of matrix, or you can understand it is a kind of matrix. So I want to access that, so I'll defining some kind of array and 2D array, so as to you could have a better understanding of how we are doing that. So basically array is a type of collection of elements of same data type. Let's say you want to store of a particular player, you want to store its test runs of each inning. So obviously all the type of innings have some runs. So basically it means it is a kind of all the entries are integer. The important part of array is basically all the data types, all the collection of elements. Basically all the elements should have same data type, right? So obviously the runs are all in the integer data type, so that could be stored or collected in an array. So you want to collect a player's test cricket runs of every inning. So you could make an array, and the interesting part of here is it does not start with the index 1. It could be just a convention. It starts with a 0 index. So basically first inning would be referred as 0 index, and second inning would be referred as first innings, and similarly, and all the elements would be stored in this container, right? Also, if you want to access, let's say if you want to access how many runs did he score in the 5th inning, then you could access obviously by using the 4th index, as I said, because the index starts from 0. So you could just access it by using the name of the array and the ith index of which you want to access it, right? Like there's an example of, let's say there's an array. This here is the data type that are in of the element that are stored in the array. So basically, since all these are integer, we are defining int here, and it is the name of the array. We are defining here the name as marks. You can define it as your own sake, and this here defines the size of the array, basically because you see there's a 6 elements. You may be confused that do we write the size is also as 5 because the last index is 5? No, we just write the size of element as the number of elements present in the array. So basically this is index 0, 1, 2, 3, 4 and 5, and the size is 6 because there are 6 elements. If you want to access some elements, let's say 15, then you would have to write marks, and since it is 1, 2, 3, 4th index, so you have to write marks, this bracket, and 4 inside the brackets. Then you can access that element. Now talking about 2D arrays, basically you can think it as of an array of array. In array, in the previous 1D array, you understood the example in which each element had the data type of integer. Now think of that each element is itself an array, right? Think of it here. 1, 2, 3, 4, 5. There are total, let's say, 5 elements, right? And each element is itself a array that contains 4 elements, right? So you can understand it in that way. Basically a 2D array is a kind of array of array, and it is also known as matrix or a table because it looks like that, and it has some rows and some columns, right? And also notice that similarly as in 1D array, the indexing starts from 0. Here also the rows and the columns indexing starts from 0, 1, 2 and 3, and here also starts from 0, right? So if you want to, let's say, access some particular elements, let's say you want to access this 14th element, so you write the name of the array. Let's say it is marks, so you would write marks, and the second row and third column, so you would write here marks, and open bracket, second row, you write row first then column, right? You don't have to interchange it because that would refers to another element. It is known that you have to write row first, so basically you write row first 2, and then you write column that is 3 here. Then you can access the element at the second row and third column, that would be 14, right? Now coming to the first subfunction of our code, and that is the printing board. Printing board, as I said, it is a void type. It does not return any kind of element or a boolean type. It does not return anything like that. It's just a function that print the board after every move. Let's say I have played a move, and then the computer or the second player have played the move, then it would print after every single move. After I have played move, it would print the board. After the computer played move, it would print the board, and similarly so on until the game is finished, right? When is game finished? Basically if either one of them win or the game is draw. We'll understand about that later in the slides, but right now just let's focus on the printing board subfunction. So basically it is a void subfunction because it does not return anything. So first of all, we are giving one line. Why we are doing this? There is no role of giving this line in the terminal for this, but we just want to segregate it from the upper inputs and outputs in the terminal. We want to have a proper layering, proper distance, so it will be visually appealing, right? So we're giving a line. Now after that, for anti I is equals to 0, I less than r, I plus plus, this is a for loop. I'll make you understand how it works. Basically you are initializing the I as 0, then it check the condition. If if this condition is true, if this condition is true, do all the work as specified in this, and then come here and do the function that is written here. Now again check the condition. Now you have to forget this because it was just for the initialization first part. You have to do this function, that whatever written here, you have to check the condition again. If it is again true, then do all the work here, then again come here, and so on until this condition is false, then you'll exit this loop, right? So basically we are initializing the integer I as 0 initially, and r is the, remember, the universal variable that we have described in the very starting of the code. It described that total how many rows are there. Basically, as you can see, there are 6 rows, so basically r is 6, and so basically I is 0. So this condition is true, right? 0 is less than 6 initially, so it will do all the works at is written here, and then again come here. I plus plus means that increase the value of I by 1. So basically initially it was 0, now it would be 1, and so on until it's 6. When it's 6, it would be 6. 6 is not less than 6, so that condition would be false, and it will exit this loop, right? So that was the flow chart of the for loop, and now we do the all the work here what this loop is describing. First of all, we are couting blue. Remember, we have described in the ANSI code, in which the blue, when we write blue, then the text next to that would appear in the blue character or blue color. The characters or the strings that would be written after this would be displayed in the blue color, right? So this line would be displayed here in blue color with some space here, and then we reset it so that when the dots are printed, it is again printed in the white color, right? So we have printed this line. Now for each row we are doing it, right? So we are doing this for 1 2 3 4 5 6, all the rows. So we have for describing its function for first row, and it is very similar to all the rows, for all the rows. So we're printing this first, then we are checking, then in that row we are moving along the columns to check if they are entries of players or not. If let's say if there is a entry of player 1, then it would appear a red cross as it is here. So if bij is, as I said, we are using, or we are accessing the 2D array of B named B. We have defined it very earlier, and it is ith row because the ith row is here as from here, and the jth column is, we have started from the j equal to 0 and we are increasing the similar for loop for rows. We are doing it inside the row. Basically for every row we are going from column 0 to column number of columns, basically 7. So for every row, for let's say 0th row we are going to 7 columns, and for first row we are also going for 7th column, and similarly for all the number of rows we are going through all the number of columns to print it, right? So that's why there is a nested for loop. For every I we are going through all of the j's, right? So we are accessing here the current value of I and the current value of j. So b of ij accessing through these two for loops covers all these points here, because as I've said, for every row we are going through every column, right? So for a particular example, let's say I'm choosing the I equal to 0 for the first row. So where it would be 0, so b0 and j is equals to p1. That means that we're checking that if the character p1 has played here, if the character p1 has played here, it would be appear something like this here, red cross. Why red cross? Because the character p1 is corresponding to the red color and the p2 is corresponding to the yellow color, so it would appear as red cross here, right? And if that's not the case and it is the p2 who has played at that place, it would appear as yellow circle. And if both of these are not the case, then it would appear simple the dot. Again, there could be a doubt, if we're outing this all the time, then why are these if else statements? Because we want the color. That's the main part. We want, if player p1 has red, do the print the that what is there, but print it in red color, right? If p2 has played, print it in yellow color, and if no one has played there, just do it in white color. So we are just checking the player for the color part. We can just directly print bij, but we want to print it in some specific color, so that's why we are checking if else here. So for every entries, if there's a red cross, yellow O or circle or 0, whatever you say, and or white dots, after finishing all the rows and columns, we are again printing a blue line here so as to signify it as a container which is containing the game. Now if we do it for every row, now after that we are printing here plus in the blue color so as to signify as the corner of the board or the container. And for this we are printing this line. Notice we are going into 2 into c plus 1. Why we are doing that? Because they are not exactly only j columns. For they are j columns of these dots or circles or whatever characters, but we are printing spaces between them, right? We printed red type of character here. Imagine if it is here, then we are resetting it to white, obviously, and also we are placing a space between these, and then again the character. So basically there are spaces. So basically they are not only j columns, they are j columns of character that would be shown, but the total space is not j only, and it is 2c plus 1. So that's why we are accessing from j equal to 0 to j is less than 2c plus 1, right? And j plus plus, and we are representing this in blue color, right? And again a plus to signify the corner, and we'll reset that so that these numbers are not now printed in blue color, and now we are printing that number here. I hope you have understand the printing board subfunction. It is a kind of subfunction that will be used after every move. So that's a very important subfunction, because this is a subfunction that describes how the game look in the terminal. Now coming to the main function, initially I've told you that these are defined as dots. These are defined as empty, and empty corresponding to the dots, as I have earlier told that empty is corresponding to dot. So basically the main function initially what we do is we put all the pieces as empty, all the spaces in the container as empty. We define it as or initialize it as empty. So we can think of the few lines, the first few lines of the main function as the physical board game before we play. We are first wiping the board clean by putting all the entries or initializing all the entries as empty. Then we are asking how to play. Basically we are giving the two modes, either to play two players or versus computer, and then we are setting the first player. We are always setting the first player as P1. So let's say there are two players playing, then P1 will play first, then P2. And let's say it's the computer playing against the player, then P1 is the player and P2 is the computer. So the player will get the first turn to play, right? And the char p is equals to p1. We're defining it as we're defining, as I've said, p would be the by p would know, we would know that whose turn it is, and we are initially defining as p1. I'll come to the main function part later on. Before that, I like to describe all the sub functions that we are using in the code. So basically this is the input, these are the lines of the few some of the few lines in the starting of the main function, and this is the output for this corresponding part. So this is this will how it appears, connect 4, and you have to a choice to play between to play two players or versus computer, right? And now how do we define, or how do we get to know if after a particular move the player have won or not? So basically what we do here is see, the win condition, as I've discussed earlier, that it is a bool type. What is a bool type? Bool type is basically just that tells us true or false, right? Yes or no. Basically after every move the computer asks one question, right, to the compiler, that the last move, did the last move win the game or not, right? How did we know that? So basically the with subfunction plays the role of checking whether any player has won or won the game. Basically it's kind of a referee, you can understand it like that. After every single move the main function calls the specialist, right? We have told that the subfunctions are kind of specialist of their work, to answer one critical question: did the last move win the game? How would you know that? Let's get to know that, right? So basically it is taking inputs as integer r, integer c, and char p. Integer r means the row in which the last character was played. Integer c means the column, the last column in which the last character was played, and the char p was the character which was played in the last move. Notice these R and these C are not the universal or the global R and C that we have defined, because those were capital R and capital C. These are the inputs that we are defining here and we'll be using here in this scope only, right? And it is a kind of bool as we have described, yes or no. So basically we define the integer count as initially as 1, because when we put the character in a particular block, obviously when we count either horizontally, vertically, or diagonally, this one present, so we'd obviously start the count from 1 and we count in the right and left both side, or vertically in which direction you want to count, and we see if there's including this if their count is greater than or equals to 4, right? So I describe one type of condition and you'll understand the rest, because these are very similar to that. These 4 are just as I've described. Here we are just checking horizontally, going through the columns. Here we are checking vertically, going through the rows. Here we are checking diagonally, and here also we are checking diagonally. So I describe the horizontal part and you'll understand how these are also working. So basically first of all we define the for loop. Basically initially we have initialized the count as 1, right? Now we are going from int j is equals to c minus 1, and j is greater than or equals to 0, j and this. So basically first of all let me define you what is and. So basically and is a bitwise operator. What it checks, and is true only when both side of this condition and is true. Let's say A and B. It is only true when both A and B individually are true. If A is also true, B is also true, then A and B is true. If any of them is false, then this whole condition would be considered at false, right? So what we are doing here, we are initializing j as c minus 1. C is the last, let's say it was the column here, right? So what we are doing here is this, we are choosing the column left to that, right? Basically this is c, let's say it is the value of c is 4, so we are going from 3 then 2 to 1 and then 1 then 0, right? Also we want to check this condition that we are not going outside the box, so we are always checking this j is greater than equals to 0 and j is less than c. When we are decreasing j, then we are saying that j is greater than equals to 0 or not, we are checking that. And if we are increasing j, j should be less than c, less than, not less than equals to, because the index starts from 0, so the last column, the last index should be the number of column minus 1, right? So we are checking here from left. So basically we have the character here, we are checking here, if it is p, then increase the count, and if j is greater than 0 and the character inside it is the same as the character p that we have initially taken as input, then increase the count and also check this. And if this is not the case, then stop the count here and check on the right side now, right? And the count would be 2 because we have found one character on the left. And now we'll check right and we'll also do the same, and we'll keep counting until the characters are the same as the input that we have taken. So I think you would have understood it. Let me explain again. Let's say it is a cross, right? It is of player p1. Then if it is cross, then we increase the count to 2, which was initially initialized as 1, and then we'll check this. Let's say if it is circle, then the count would be remain 2, and we'd not check now the more left one. Now we'd check right ones. And if right it is cross, then we'd increase the count to 3, which was 2 earlier here from here. Now it is 3, and we'd check again one right block. And if it is also 4, then we'd again check here, and we'll do the same until the character is not the same as the character of here, that is cross in this example. And we'd and after doing all that, when these condition is false, either of these will eventually false, either the array that would not contains that character, or either these condition will be eventually false, because we are decreasing j. So there will be a time then in which j is less than 0, and similarly we are increasing j here, so there will be condition that j is greater than equals to c. So in that case, it stop it and return true if the count is greater than equals to 4. And if count is not greater than equals to 4, redefine it, reinitialize it as 1. Why? Because now we are thinking in the vertical direction, so we don't need any count number in the horizontal. Now we again define it as 1 and check in the vertical column. In the initially we'll check the upper part, and then we'll check the lower part, and similarly we'll go with that. If there's count is greater than equals to 4 in vertical also, then we'll return true. Otherwise will not return anything, and we'll again reinitialize count as 1, and we'll check diagonally one side of diagonal. If that is also not corresponding, then we'll check another side of diagonal. If in any of these condition the count is greater than or equals to 4, then we'll return true. And if that's not the case, then we will eventually return false. If any of these conditions are true, basically either vertically, horizontally, or any of the diagonal, will say yes, you have won the game. And if that's not the case, then we'll say default it is you have not won the game, right? So now let's discuss about two of more of the subfunctions that we have used in our code. The first is the checking draw, and the second is the determining row. Notice we have used the int r as the row as in input in this boolean type of subfunction. But how are we choosing r? Because remember I said that the player can't choose the row in which he want to play the character. He can only choose the column. So we are determining the row by another subfunction called the drop. Right, so we are using this subfunction drop to determine the row in which the character would be placed. Obviously, it would check from the lowest row possible, and it would, if that's empty, it would place here. Otherwise, it would check for the just upper row, then the lowest, and so on. It would keep on checking until it finds an empty block, so that it could place that character in that row of that particular column. Right. Obviously the column would be given as input when you have a choice. The player would have choice to pick a column between 1 to 7. So this column is basically an input, and the char p here is the character of that player. Basically, if player p1 is playing, it would be p1, and if the character p2 is playing, then it would be, or the player p2 is playing, it would be p2, right? So obviously there's an or gate here. Remember I told you about and gate, in which the all the conditions has to be true if the whole condition is to be true. So in this, if any of the condition is true, then this condition would be, the whole condition would be considered as true. So that's the difference between and here, because in and you have to determine all the condition has to be true, if so that condition is true. But in this, any of the condition, if it is true, then it would be considered true. So basically these are all invalid condition. Basically, if the column you have chosen is less than 0, or is equals to greater than c, equals to here because the index is starting from 0, as I told you, or the column you have selected is already filled. How do you check that? You just check the most highest row. Basically in this, it's 0th row. So if you check the uppermost row, 0th row and of the column, then you would say if that is not empty, then basically obviously all the down are filled. So basically that column is not empty. So we check these three. If any of these three is the case, so that is basically an invalid move, and it will return -1. In the main function, we check if it is -1, then you say we want the input again, and it will be continue, right? We'll check that later. So basically and if that's not the case, if it's a valid move, then it would for anti-r -1 basically starts from the lowest row and check for all the empty spots. If the first empty spot it finds, it will put the character there, and it will return the I basically that row in which it would be the row, right? And that will be using in here, and some of the sum function in the later part, right? And how do we check if the right now the situation is draw? We check if when it would be the game would be draw, when the whole box is filled, there's no space left. And how do we check that? If all the top rows, or in the top row, if all the columns are filled, then basically that means that there is no space available now, and that would result into draw. So we'll just check, we'll take the bool as the data type of the sub function, obviously, because it will tell yes or no, is it draw or no. So basically it will be bool, and we're checking at the highest row and checking all the columns. If any of the column is empty, that means there's still a condition of play, and that would say that it is not draw now, right? If it should be full completely, then we can only say that the game is now draw. Okay, now we have talked about these sub functions. Now let's talk about the computer's approach. Obviously the AI, the proper AI, which can think of like 5 or 6 steps ahead and do the best move possible, that is not in the scope of our discussion right now. We have made an algorithmic approach for the computer that the computer should follow, and computer would follow, and that would increases its chance from just some random moves to some strategic moves. What are these? Basically the computer's algorithm is designed in 3 steps, right? The first step, and it is in the priority order, the first step is to look for any winning move. If there is any move in which the computer will play and it will win the game for the computer will play that move. If that is not the case, and then it would check for any move that if the opponent player will play in the next move and he will win, then computer will wants to block that move and it will play there. So basically the first priority order is check for the winning move, and the second is check for the opponent's winning move or blocking the opponent's winning move, and third is if these two conditions are not fulfilled, then the least priority is then we just place your character in the center preferred. We have a center preferred vector here, and we'll check for if this column is available, then we'll place the character in this. If this column is not available, then we'll place the character in this, and this is center preferred. Like this, the 3 is the center of the center column of the grid, and then this and 2 and 4 are like the just side of the centers, and so on. So basically we'll check from this preference order if this is allowed to, if this column is not totally filled, then will computer will play in this column. So basically it is the priority order. Look for the winning move, look for the if that's not the case, if there is no winning move, then look for blocking the opponent's winning move, and if that is also not the case, then prefer a center position and play play in a center preferable situation or column, right? How do we know that? How do we know that any move is winning or not? Think about it. Like, how do a human understand if there is a winning move? We play the game in our head. We play the next move in our head, and we check if that lead to win or not. How did the computer would do that? The computer would do that using the try move sub function. What does this do? Try move sub function is a boolean type, right? It will just tell that if I'll try this move from any character. See, notice we have given as input as character. We have not only given it p2. We're not only concerned about the computers, we're also considered about the opponents. So we'll checking for both char. So basically it is input as column and char, and it would check if in that column if the player or the computer moves, then if there is a winning for any of them. So basically we have taken input as column and char p, and if for int I equals to r minus 1, I greater than equals to 0, I minus minus, if b of I column is equals to empty, basically for the lowest position, lowest available row, if that row is empty, we'll place the character p and in that row and in that column, and we'll check if that leads to win or not. Regardless of it is win or not, we'd make that row and column empty again. We place the p, we check if it is win or not. We have stored this into the OK type of boolean parameter. So we have stored it into OK. Now we have empty it so that it is the same as before, and we'll return OK. And if that's not the case, basically if there is no empty situation, then we'll return false as well, right? So this is the try move sub function. Just like we think about the next move in our mind, similarly computer also think of all the possible move for the turn without actually changing the same real game board. How is it not changing the real game board? Because of this. Because when we are putting the character in that position, but after we are checking if there is a win or not, we are again putting it as empty situation, at empty as it was before this function, right? And we're checking if there is a win for any character or not. So how now this is the try move sum function. Let's go back to the AI move sum function. So basically, as I said, it is in the 3 priority order. This is an integer return type because it will return the column in which the AI should play. So this is the integer return type, and it is not taking any inputs. So it will, how do we play that? For every column, c is equals to 0 to c less than c. C is the global variable c. So for every column we check that if b of 0 c, basically this means that if that column is empty or not. If that column is empty, and basically this and means that this both of these should be true. So if this is empty, basically that column is empty, and the we'll move that try move, we using the try move sub function. Again I'll explain it. We'll choosing that column c and the character p2. Character p2 refers to as the character of the robot or the AI. So the robot will play its move in the c column, and if it is true and the column is not fully filled, that is satisfy this, then we'll return that column to be the AI move. And if that's not the case, basically this would be true for many cases, but this might not be true for many cases. If this and this both are true for any case, then we'll return that column for the AI move, and we'll not look into all these. And if that is not the case, then we'll look for this, and in this we are playing the p1. We are placing the p1 so that if the opponents play, the computer's opponent play in the next move, and if there is a move that can lead to the victory of the opponent. So we are checking that also, if there is, and obviously this condition also, if that column is empty or not. then if both are true, then we'll return C. So first priority, if this does not return any C, we'll check this. If this also does not return any C, then we'll just randomly play, or not randomly, we'll play the center preferred. If this is available, then we'll play in this column. If not available, then 2, and then some, and then goes on, right? Least priority, from most priority to least priority, right? So these are the algorithmic approach for the computer to play. I hope you have understood what our computer is gonna do and how it would be lead to that algorithmic approach to the problem, right? Now, since you have understood all the sub functions in our game, let's understand the main game again, and just summarizing all the subtopics and all the sub function that we have read till now. Let's go deep dive into it. So basically, this is the int main, as I've described this earlier. We are initially setting the setup. We are initially setting the board as empty. So we are initializing all the pieces, all the indexes of the matrix of R row and J columns as empty initially. Then we are asking the player if they want to play 2-player or computer, and we are getting the input as mode. We are defining the initializing the integer mode, and we're getting that input as mode. And initially we're defining P as P1. Basically P defines the whose chance it is right now. So we are initializing it with P1. That means that we are saying that the first turn is of obviously P1, and then we have made a while loop. While true is basically it will run until we use any kind of break, or if any situation comes in which there's a break written in that code, then only it will exit the iteration. Basically, think of it as that game would be continuously playing. How would a game stop? Either if any one of them wins or the game is drawn. So basically we're checking the win and the draw after every move, and if any of these has been completed, then we'd exit this loop. Otherwise this loop will be continuously playing, right? So and obviously after every move we want to print the current situation of the board, so as to player know as the current condition of their game, and obviously it is also visually appealing. So we want to print the board after every move, right? Initializing, we are defining the column in which the we are initializing the column in which the character would be placed. I'll define it later, I'll explain it later, but we are initializing it initially -1, and then we are saying if P equals to P1 or mode equals to 1. The equals to means, first of all, if I have not told you earlier, if there was there were many instances of equals to. I may have not explained it earlier, but I'll explain it here, right? When you say that this equals to P, then we initialize or define the value that in the 2D array of char B, the rth row and jth index is equals to P, right? The character P. But when we do equals to, then we are checking if the value in it is equals to this value or not. So this is the kind of it is used for checking the condition, and if we are only using one equals to, then that would that was used to assign value. So we have to use double equals to check if these two values are equal or not. We can't use A equals to B, because that would assign A equals to B, and that would obviously be meant as true, because since A equals to B and it's checking A equals to B, that won't make any sense also. So don't use that. Always use double equals to in checking conditions, right? And we have used that double equals to many times, so I hope you have understood why we were using that. And now see, so where were we? So we have in this condition we are checking two things using the OR operator, right? If P equals to P1, if the turn is of P1 or mod is equals to 1. What does it mean? See, when does computer play? Computer play when either the mode is it should have mode equals to 2. Obviously, if there is a mode 1, then obviously it means that it is of 2 player, so there's no role of computer, right? So computer has to be computer will play move with two conditions. First, the mode should be 2, and the P should be P1, right? So if any of those conditions are not fulfilled, then that it means this, right? If any of P equals to P1 or mode is equals to 1, then we'll take the input from the user, and else then the computer will play its move, right? So now defining these things, string player color is basically red or yellow that we have defined in the starting. So obviously red and yellow is a string, so we're defining string player color equals to, and then this syntax may confuse you as a beginning, but this is just an if else in a synthetic sugar, like sugar coated, right? So basically it's just an if else. If P equals to P1, that means if the current turn is of P1, then the player color should be red. And if that's not the condition, if this is true, then this condition, if this is not if this is not true or this is false, then this condition, right? Just when you write if this, then this condition, else this condition, exactly. If this is true, then this condition. If this is not true, then this condition. So if the turn is of player P1, then it should be red player color, otherwise it should be yellow, right? And also we're assigning the value of P here using the same. If P is equals to P1, then P should assign a value of 1, otherwise P should be assigned a value of 2, right? So, and that would be we would be printing that here, so that to say that whose turn it is, and it should be in the same color as the symbol of the player. Let's say I have the player 1 has a cross of red color, so it should say player and open bracket, and 1 should be in the red color as well, and then we are closing the bracket and say player 1 choose column 1 to 7, and we're seeing this, we are taking the inputs, and we are doing C minus minus y because the index again starts from 0, and we're taking the column as entry, so we want C minus minus as the index that we are accessing, right? Else the computer's move, C equals to AI move. I have already explained the AI move subfunction pretty clearly. So basically we'll just take the inputs, take the C as the AI move, and we'll say that computer chooses the column. Again, C here is the index, because in the computer it is using the index, but the column it should be C plus 1, right? Because computer knows the index correctly, 0 1 2 3, but we want the user to see he has chosen which column, so column should start from 1, right? So basically we'd say C plus 1, and we'd end obviously. And now we're assigning the value of R in which row. We are assigning the row, and we are using that drop sub function that we have explained earlier. And we have said that earlier in all the false condition or invalid move condition, R was assigned as -1. So if R is equals to -1, then say C out invalid move. So we are printing that it is an invalid move, and try again, and we'll continue the game. And if or else, basically this is the condition. If this is, obviously this would not be in most cases, the user would print some valid move, then we'd go from this flow. And if that the last move was a winning move, then we'd say print board again, obviously print board, because after the win has been displayed, obviously would print again, right? And the string winner color would be, again, if it is P1 who has played the move, then it should be red, and if it was not the case, basically P2, then it's yellow. And string winner message would be, again, if P equal to P1, then player 1, else there should be two conditions. If there was, like, the mode was 2, then computer won. If the mode was 1, then player 2 have won, right? So these are the condition for that. And then we see outing winner color, winner message, and win. So winner color is winner color here would be red or yellow. It would not be displayed. Again, this is just to tell that the next text should be in this color. Basically, if P equals to P1, then here it would be red. Red would not be printed in the terminal, but it would tell the compiler to that this winner message here, if the P equal to P1, then it is player 1, so it should be written in red, right? So red wins, the player 1 here, so not red wins, it would be player 1 wins, and player 1 would be written in the red colors, right? And it would be again resetting that to the normal format, normal default condition in the terminal, default color, right? And if that is also not the case, if no one wins after the last move, we'll check the draw condition. If that is also not the case, obviously if draw, and then print board and say it's a draw, and would break the while loop. And here also we are breaking the while loop, because as I've said that we'll break the game when either one of wins or it is a draw. And if that is also not the case, then we'll just we'll just say that now if the player P1 was playing the move, now P2 has the chance to play the move. So if we are assigning P is equals to, if P equal to P1, then we are assigning the value of P2 now P2, and if it was P2 earlier, then we are assigning the value of P to now P1, right? And that's how the game works. So let me show you the output of the game, and that would be it. So let's see the output. Okay, so now let us look at the output at the terminal of the game. As you can see, the whole code is approximately 150 line, right? And it is not that large, but we tried to understand the importance and why did we write every single line of the code. So that took quite large time. So let's see the output of this, right? So I'll run it. Okay, is there some mistake here? Okay, so let us look at the let us try to look at the output at the terminal of the game now. As you can see, the whole code is approximately 150 line. It is not very large, but yeah, we try to understand why we have written every single line, and that took a large time pretty much. So nevertheless, let's look at the output at the terminal, and let's play the game for once. So basically, as I've shown you that there's the name of the game first, that would be appear, and there would be have two choices basically, to play two-player game or versus computer. Obviously it doesn't have another player right now, so let us play against the computer. Also we'll try to look at if the algorithm that we have fitted it into the computer, is it working properly or not. Is it going for the winning move first, or then blocking the opponent's winning move and then the center prefer or not? Let us look at that, right? So let me play against the computer. So for now, let's say I chooses the column 5. Right now, see, the most centered is this column, right? So right now there is no winning move for either of us, so it is just preferring the center and playing the game. So let us also play at the fourth column right now, and you'd see that it is again playing in fourth column. Yeah, it kind of it may feel kind of repetitive at times, but it is still better than the random moves, because in this game the computer has a greater chance to win, right? Because it is center preferred one, and also there's proper algorithm for that. It's not just center preferred, right? So let us now play. For example, let's play in the fifth column, and it is obviously still playing in this. Now what happens that if again I play in the fifth column, if now I play in the fifth column, there's a chance of me to win if the computer does not play in the fifth column and again I played in the fifth column. So obviously computer wants to block that. Basically right now there's no winning move for the computer, so in the priority order now it will try to look for any move to block my winning. So if I play in this fifth column, the computer has to play in the fifth column to stop me from winning the game. So the computer has played in the fifth column. That was the algorithm, so it is properly working right now. Okay, so now in which direction should I play? Let's say I play in the there's no winning move for computer right now, right? So let us play in the third column, for example, and it has played in the fourth column. That's not an issue right now, because if you can see the computer is going to win in the fourth column if he plays again. So I'll block it, obviously. Just like we did this calculation in the mind, the computer also do the one-step calculation in its mind, as I've told you earlier. So let us play in the fourth column, so block that. Now the computer has played in this move, and as you can see there's connected 3 here, so I'd have to block it I have to play at the 2 to block it. So let's play at the 2 to block it. And okay, This is going to be little bit trickier. I don't think there's a winning move right now, or there's any kind of he'll play at here and then I'll block it. That's not an issue. So basically, or rather, should I just block it right now so that it does not bother me in the future? So okay, that's the okay. How should I look for the win? So let us play at the sixth column right now. Right, I don't think there's a winning move for the computer right now. So just let's play in the seventh column right now. Okay, he has connected 3 here, and next time he'll try to play in this move, so I'll block that. Okay, this is of no use, I think, right? So this all is just wasted now. I'll try to look for my winning move. If I'll play in the, yeah, so I think no. He'll play in this move, and then let's play in the sixth move. Okay, sorry, I see. I chose the fifth move instead of six, and since it is already filled, so it said invalid move, and I have the choice again. So that was also a part of code that I have written. So let's play in the sixth move. I would say sixth column. Okay. Sorry, I didn't saw that there is also 4 like there for the computer. Okay, so computer won. So we have made a pretty good algorithm to play. So that was the game. I that was the game. I hope you have liked it. Thank you for your attention, and let's move with the next slide. Thank you for attention. I hope you have liked the game. That's it for me.